So today we are continuing our review with intercepts and slopes. So an intercept is the point where a graph crosses an axis. So the point where the graph of a line crosses an axis. So we have the x-intercept and the y-intercept. So if we have a quick picture of a graph here, and I draw a line through there. This point here, where it crosses the up and down, or the y-axis, that's my y-intercept. And this point where it crosses the horizontal, or x-axis, is called my x-intercept. So the intercepts are the point where they cross the axes. And just as a reminder, at the y-intercept, by definition, x equals 0. Right, when I look at this point here, I didn't go off the axis at all in either direction. I have no value to my x, it equals 0. So by definition. And at the x-intercept, the y equals 0. That will always be the case. When I cross this x-axis right here, I haven't gone up or down. I'm sitting right on the axis, so the y value is 0. And I can use those definitions to solve for the intercepts. So the instructions in the assignment say solve for the x and y intercepts. So this is number 5. And if I look at that, if I want to solve for the y-intercept, I know that that's the point when x equals 0. So my equation was 2x minus 10y equals negative 30. I can replace x with 0. So 2 times 0 minus 10y equals negative 30. This part goes to 0, and I'm left with negative 10y equals negative 30. Divide by negative 10, and I get y equals 3. It looks like a positive. I'll see if I can fix it really quick. Nope, not going to be able to. Divide by negative 10. So it's important to remember that the intercept is at y equals 3, but that's actually a point. It's the point where x equals 0 and y equals 3. The intercept is one point on the graph, so it has the x value of 0 and then the y value that's given. If I want to solve for the x-intercept, I'm going to use the fact that y equals 0. So my equation, 2x minus 10y equals negative 30. I'm going to put 0 in for y this time. So 2x minus 10 times 0 equals negative 30. This is going to go to 0. So I have 2x equals negative 30. If I divide both sides by 2, I get x equals negative 15. So again, I can say that my x-intercept is negative 15, but I have to remember that's a point, negative 15, comma, 0. And one of the reasons we like these is that we can use these intercepts to graph any equation, right? It's just a quick way to graph them. So number 15 is another example from the problem, and it said to find the intercepts and graph. So let's start again with my y-intercept. You might notice that this is in slope-intercept form and not go through this trouble, but for practice, at the y-intercept, x equals 0. So y equals x plus 3 becomes y equals 0 plus 3, or y equals 3. So my y-intercept is the point 0 from x equals 0, comma, 3. My x-intercept is the point when y equals 0. So my equation, y equals x plus 3, when I substitute that in, becomes 0 equals x plus 3. And to solve this one, it's only one variable. I know how to do that. I need to move this 3 to the other side of the equation. So I'm going to subtract 3 from both sides, and I get x equals negative 3. So my x-intercept is negative 3, or the point negative 3, comma, 0. Okay. So now how do I use that to graph? I have a set of coordinate axes here. And I'm going to draw a few little crosshatches. 1, 2, 3, 4, 5. 5. That's enough. Each one of these is worth 1. Right? If I start with my y-intercept, my x value is 0. I'm right on the line, and I go up 3 spaces. And that's my y-intercept. Now I have an x-intercept, so I'm going to stay right on my horizontal line. I'm not going to use the y, and I'm going to go back 1, 2, 3 for negative 3. Now I have 2 points, and 2 points is enough to make a line. I just draw a line right through those 2 points, and that is the graph of my line, y equals x plus 3. Okay. There was one problem that was giving students a little bit of trouble during class, so we can look at it really quickly. The y-intercept is when x equals 0, so y equals 3 times 0 plus 5, y equals 0 plus 5, so y equals 5 is my intercept. Again, you can look at this and see that it's in slope-intercept form, and just read it off, that's fine. So 0, 5 is my y-intercept. But let's look again at the x-intercept. My x-intercept, let's see, my x-intercept is when y equals 0. So if I rewrite my equation, that becomes 0 equals 3x plus 5. So I have to solve this equation. I've got to move this 5 to the other side. So subtract 5 from both sides. Negative 5 equals 3x. Now I have to get rid of this 3. It's multiplying, so I'll go ahead and divide it. And I end up with x equals negative 5/3. This was the only problem on the assignment that was a non-integer intercept. I think that just made students think that something was wrong, and it's not. That actually is the correct answer. And that's okay. There's no rule that says it always has to cross right at a line. The intercept is negative 5/3, 0. That is correct. So just to show you, if we were going to graph that, I'm going to run right through my work here. The y-intercept is easy, 0, 5, right there. This other point, negative 5/3, it's not an integer. It's not going to be right on one of these points. I know it's less than negative 1, but it's not quite negative 2. Just draw a point in between them, and that'll be fine. And then connect them with a line. So there you go. The other thing we talked about was slope. And so if you remember, slope is just a measure of the steepness of a line. And not only does it tell us how steep the line is, but it tells us whether that line's going up or down. So we have 4 possibilities for a line. We can have a positive slope. Okay. So as you look at this, as you're reading across the page, if the line goes up, it's positive. If you look at it as you're reading across the page and the line goes down, that's a negative slope. And then there were 2 other possibilities. What if this line doesn't go up or down at all? If it's just flat, a horizontal slope, that slope is equal to 0. Or what, oh, that was bad. What if you have a line and it goes straight up and down? This is called a slope is undefined. Right? It's so steep, it's infinitely steep. I cannot make a definition for how steep it is. I just say it's undefined. It's too steep to define it. Then, so we have those 4 possibilities. And then, oh, I didn't erase the end of my work down here. Let me see if I can. I can't do it right now. Okay. Slope, we use the letter m. And to do that, it's a measure of the steepness. We talk about rise over run. So how far up does it go versus how far across? So we can do rise over run, or we can say that the slope is y2 minus y1 divided by x2 minus x1. So I still have this work down here. If I had an example of a point 0, 5 and a point 2, 7, and I wanted to know what is the slope that connects these 2 points, I could do this equation. y2, I take the y from the second point, minus y1, which is y from the first point, so 7 minus 5 equals 2. x2 is 2 minus x1 is 0, so 2 over 2. 1, my slope is 1.